Now I think what we also want to add is some sort of graph to keep track on how many dots we have in our little simulation in the dot world. And this is actually probably the most difficult bit. So if you're satisfied with your simulation, you can leave now, of course, but I really like to have some graph that updates. We have to do that with an XY array and overlay it on our game image. So let's go to, and here at the start, after we have added infected people and before our clock, we will say that we have some stats, which will be Pygame, and that will be a surface 1/4 of the width and 1/4 of the height. There. So this will be a window in the top left corner, and we'll make this gray. We haven't defined gray yet, but we will in a short while, and we will say that our stats dot set alpha, we'll make it see-through. This function takes values from 0 to 255, so we'll go to 230, so that'll be see-through enough, I think. And we'll say that the position of this guy is 1/40th of the size of the screen. There. Let's define green, no gray. And in this graph, I think we will include deaths as well, because they are simply removed from the image right now. So let's just go gray first, 230, 230, 230, and dead people will be a horrible yellow. This color is very horrible. There, down to our stats again. Okay, so that's, now we've initialized the surface. We haven't drawn it or anything, which we will do soon. We will do that before we check for new infections. So update stats. The stats height. We need these variables, so we just extract them, so we don't need to write as well. Will be stats.get height. And stats width will be stats.get width. So, and the number of infected now is the length of self.infected container. The number of, or the entire population now, because that may change if people die, is self.all, the length of that guy, and the recovered now. We'll check for each iteration in this loop how many recovered, how many we have in the population, and how many are infected. Self.recovered container, so the length of that. And the current time, and we need this to be an integer value, will be, so we iterate over I. You can see that up here. We'll see how far we've got up to the capital T, and we multiply this with the width of our stats chart. And we do this because we want to plot some graphs, right? So this T is our X value, right? Sort of our first axis on this graph. And here we compute, okay, how far to the left in the integer value as a function of how much time have elapsed in our simulation are we? And we'll fill the graph so there'll be a full color. So the number of infected will go from bottom to top. And the problem now is that this will be an array and not a plot like in Matplotlib. So the indices goes from left to right, 0, and then upwards to n or t, and then from top to bottom instead. So this will be a bit confusing, but so we'll say that the height that we need, the number of infected, will be stats height minus n infected now divided by n population now times stats height. So stats height is the height, but we go from 0 to the top, so we subtract the number of infected to know how far down we need to go, because I hope you understand. Just think about it just a while and I hope you'll get it. Does this need to be an integer? Yes, it is already, so it's fine. And then y dead. So we need to multiply this with the height again. This time we'll go from the top of the graph and then downwards. So this here we don't need to subtract this from the height. So we'll do self.n minus n population now. So these are how many have been removed from the initial population, which is this n. And this n we initialize up here, don't we? Okay, and then we divide by self.n. So that's the share of the initial population that has succumbed to the disease, and we multiply this by the stats height, so we see how much we need there. And then one last y value, y recovered, and this we add on top of or underneath again this y dead variable. You'll see how this turns out in a while. So here we have n recovered now, and we divide by the population now and multiply by stats height. Now what we do, we make a graph, stats graph, because what we have thus far is just a box on top of everything, and this will be a pixel array, and it takes one argument where we want to draw it, which will be on this stats window. So we'll say stats graph t y infected all the way to the end. So this will color an area, will be the color of pygame.color green, which is the color of sickness, at least in our simulation. And on this same stats graph, t from 0, which will be the top, and up to y dead, we'll have pygame.color horrible yellow, stats graph. The last bit is the recovered t, so this will be from the dead because we'll draw that underneath. So first we'll have a window, and the dead people, they will be a colored area downwards, and from there and up we'll have the recovered. Yeah, this will be from y dead to y dead plus the recovered, equal pygame.color purple, right? That was the color of. Okay, so now we have drawn a bunch of stuff. It's okay to find this a little bit difficult because it's not very trivial how these indexation works, right? So before we can draw everything, and before we update the screen, we need to kill stats graph, because what this pixel array thing does is it actually locks what will be our stats window or the surface, so we cannot do anything with it, we cannot redraw it. So after we have killed stats graph, we can unlock stats, and then we say that we can draw stats at the stats position. Then we can update the rest of the screen. Whew. Okay, let's check. Bound to be a mistake somewhere. Yes, horrible yellow. Oh, stats graph. Damn it. There, let's try it again. It's probably another error. If that's the only one, then I'm a genius. I am. So here you see the infected is going up, so this function as it should. And here we have people starting to recover. So this was a quickly spreading disease. We only have recovered people and no one dies. So we have one guy left there. What are the odds? I think I might have done a mistake with the kill switch, or the functionality that checks when people dies.
A few moments later.
Did I do it the same color? Yeah, it's also purple. My horrible yellow values are wrong. Nice of you to spot that. So 190, 175, and 50. Well, that's a very horrible yellow color. Now you see that people are kicking it. I hope. After 200 cycles, which will be about here. Yeah, there you go. Some yellow stuff appearing, and a few recoveries. Oh no, what a horrible disease. yeah, well, other guys died there. Quite cool. Yeah, I like it. Okay, the last thing I want to implement is to allow for quarantines, for people to stand still, essentially. And the way we'll do that is we will also have a self.n quarantined, which will be 0 by default. And when we start the game, we will initiate the number of quarantined the same way we do the susceptibles. They will be susceptible, but we will say that the velocity is 0. And the problem, we will probably see some hiccup with the randomization functionality, so we need to change that as well. So these guys cannot be randomized because they need to stand still. And apart from that, they should all be the same. Random positions, velocity, you don't randomize. They're blue because they're susceptible. They're added to the susceptible container and to the all container. So now we can say that, alright, so what if these 100 guys, what if only 20 of them move, and we say that we have the rest of them in quarantine. And then we try. Yeah, we did an error. Do you know what it is? I know. When we copied this thing, we iterated over susceptible 2 times, and this should only be quarantined. And I think also the total population that we compute is wrong, because we need to add the quarantined as well. Where it is? Here it is. So we go plus self dot n quarantined. Yeah. So then our stats will be correct as well. All right, here we go. Just a few infected people. Yeah, this was actually a bit boring. But now you sort of see from this this random simulation that we have indeed flattened the curve. The mortality rate is still a bit high. Let's do one more with a few less quarantined people. Yeah, let's do 40. I would say that our mortality rate is 0.2. Let's go. Alright. I love this. Apart from the fact that we are talking about people that are dying. Look, there they are. Just a part of the statistic now. Yeah, and then more and more people recover. That's what we want to see. And now we have people that haven't been infected at all. So I hope you enjoyed this video. It's very fun to make, and I hope you will have fun with it as well. It's also a very good introduction to Pygame, I think. There are ways, of course, to make this interactive, to become a real game, but I find that the framework Pygame was very well equipped to handle this sort of situation with a disease simulation. So that's it for me for now. Take care.